Hey guys, so today we're going to go through the one-point gradient form as part of coordinate geometry and linear relationships. So the aim of this video is that you should be able to calculate the equation of any straight line when you have 1 point and you have the gradient. So the one-point gradient form is also called a point-slope form. They're both the same thing. We use this when we need to find the equation of the line when we only have the gradient and 1 point. And it doesn't matter what the point is. It can be any point on that line. When do we mainly use this? Well, we mainly use this when we do not have enough information or clear enough information on what the y-intercept of a line is. Because if we know the gradient and we know the y-intercept, well, you can very easily find the equation of the straight line using the gradient slope form, which is y equals mx plus b. However, if you can't see the exact point of the y-intercept or you don't know the y-intercept, then you're going to have to use a one-point gradient form. So the one-point gradient form is a very useful formula, and you have y minus y1 equals m x minus x1. Now, if you've done any of the videos on midpoint, gradient, or distance, then the y1 and the x1 will make sense. And the m will make sense as well. Now, the m is the gradient, or we can also call this the slope. And if you don't know how to calculate the gradient or slope, go watch the gradient or slope video. x1 is your x value of the 1 point. And y1 is the y value of the 1 point. And we leave y and x as variables. So let's go through a few examples on how we use the one-point gradient form. But before we do that, let's go through the steps. Now make sure you write this formula in the back of your book on your formula sheet so you can refer to it whenever you need it. So the first step is to calculate the gradient or the m value using either rise over run or the gradient formula, which is y2 minus y1 over x2 minus x1. If you don't know how to do step 1, go back and watch the video on gradient. Once you calculate the gradient and you've completed step 1, then we move on to step 2. And step 2 is use the 1 point given in the question or on the line and the gradient to substitute into the formula. Well, which formula are we talking about? We're talking about the 1 point gradient form that we discussed above. Because you'll calculate the gradient, okay, I know the gradient, and you have an x1 and a y1 coordinate as the 1 point that you know, any point. Now, if you know multiple points, you just pick one of those and use that one. Step 3, expand the bracket section, which is mx minus x1. So if I use a highlighter, that mx minus x1 is actually that part there. So that's saying expand that section. And when we do a few examples, it'll make sense what that means. And step 4 is to rearrange whatever you have then to change into the form of y equals mx plus b. Let's go through an example of using these steps just so everything makes a little bit more sense. Step 1. Let's read the question first. What is the equation of the line of a line with a gradient of 2? So my gradient is 2. I write that there. M equals 2. And this line passes through a point, 3, 6. So they've given me 1 point and they've given me the gradient. And that's why it's called the 1 point gradient form. So the first point, 3, 6, is x1, y1, 3, 6. So now I know the 3 things that I need in order to do the 1 point gradient form. I sub it into the equation. So we've done step 1, we've done step 2, and now step 3 says expand this bracket here. What does it mean by expand that bracket there? Well, that means 2 times x, which is 2x, and 2 times negative 3, which is negative 6. So I've expanded that bracket now. I've removed the brackets. And step 4 says rearrange to change into the form of y equals mx plus b. Well, right now, if we look at the black section there, that's y minus 6 equals 2x minus 6. So y is not by itself. I need to make y the subject. And in order to do that, I need to get rid of the minus 6. Inverse of minus 6 is plus 6. Basic equations, whatever I do on one side, I have to do on the other. So minus 6 plus 6 is 0. So y equals 2x plus 0. But I don't write the plus 0, I just write y equals 2x. That is the equation of the line that has a gradient of 2 and passes through point 3 and 6. Let's go through another example. But this example is a little bit different. This says, what is the equation of the line of a line that goes through these 2 points? Well, step 1 said, find the gradient of the line. The gradient's not given here, but I can calculate the gradient using the gradient formula, which is y2 minus y1 over x2 minus x1. So, in order to do that, I need to first label my coordinates. First x, first y, second x, second y. Now, chuck it all into the formula and be careful of your negatives. Remember, it's x2 minus whatever x1 is, minus 5 minus 3. Those two minuses become a plus. So just be careful of your negative numbers. Now, I've found my gradient to be negative 1. Now that I know my gradient, I have my gradient and I have 2 points. I can use any of those points. Just to keep it in the right syntax, I'm going to use the first point as I've already labeled it x1 and y1. However, if I use point B, I'd still get the same answer. So now, next step is to sub everything into the formula. x1, m, and y1. Then, before I can expand the bracket, which is the next step, I need to simplify this minus minus in the brackets. That becomes a plus. Next step, expand the brackets. Minus 1 times x, minus x, minus 1 times positive 3, negative 3. And the last step is to get y by itself. Make y the subject of the formula. So, it's y minus 2. Inverse of minus 2 is plus 2. Whatever I do on one side, I have to do on the other. So now I'm left with y equals negative x minus 1. The gradient of this line is negative 1. The y-intercept of this line is negative 1 as well. Let's go on to example 3. Now example 3 says, what is the equation of the line graph below? Now remember, we said we use the 1-point gradient form when we don't know the y-intercept or it's not clear enough. So if I zoom into this graph here, the y-intercept there is not clear enough. I can't guess it. I need to find its exact value. So I need to use my rise over run to calculate the gradient. So how do we calculate rise over run? Well, if you don't know, go back and watch the video on gradient, but we find 2 points that are exactly in the corner of one of the grids, make a right angle triangle, it rises 2 and it runs 3. So my gradient is 2 over 3. I have a point, I'm going to use point B, which is negative 2, 3. I could use any points that's exactly on the corner on this line. The only points that I have exactly on the corner are A and B. So I'm using B in this case. So now I have my gradient and I have my 1 point. Chuck it all in the formula, expand the brackets, get y by itself to make y equals 2x over 3 and 4 over 3 plus 3 will give me my y-intercept here. So 4 over 3 plus 3 is 13 over 3. So now I have my gradient and I have my y-intercept. My gradient being 2 over 3 and my y-intercept being 13 over 3. I have my equation of this line here. I have a few questions for you to do. Pause the video, try them out yourself. If you get stuck, go back and watch the examples again. There's the answers. Hopefully you got them all right. If not, go through the working out, watch the video once more, just to make sure you figure out where you went wrong. Till next time, take care, guys.